Welcome to revision week 10. There's quite a lot in this one, so we are looking at standards, protocols, important protocols, and why they're kept in layers. This is paper 1. Make sure you have a revision sheet 10 with you, with a pen ready to fill in and complete this sheet as we go along. Okay, starting from the very beginning of this, what are standards? We covered this at the start of looking at networks and protocols. So standards are a set of requirements that are used for hardware and software. Requirements, okay? Not rules, requirements. They make it possible for manufacturers, for people that create technology, to produce products that are compatible with each other, which work together. Without standards, a lot of things wouldn't work or wouldn't be able to interact and wouldn't be able to communicate and work together. So think a standard way of doing something, okay? A set of requirements for hardware and software. Think these are examples of standards that you should have in your mind, okay? Character sets. A character set is a standard way of storing text on the computer. Things like ASCII, Unicode. Web pages. Use HTML. The language is a standard way to display web pages on computers across the world. We have protocols that we've talked about, things like TCP/IP, POP3, email, etc. Those are a standard way, a protocol to communicate and transfer data. Standards. We have cables that are standards, things like USB, Ethernet. They are standard cables that are used for different computers and purposes in the network, connecting printers, connecting mobile phones, etc. Standards. And finally, file formats. All the different file types you use, doc, PowerPoint, JPEG, and MP3, they are standard file types that can be opened by different programs and devices across the world. So, standard, a set of specifications or requirements for hardware and software. They make it possible for manufacturers to produce and create products which are compatible with each other. Without it, you wouldn't be able to interact or communicate with each other. And the examples we had there on the screen. Okay, complete the sheet, please. What is a standard? Why is it important? And give me some examples of things that use standards. Pause, complete, and then check. Okay, ready to check your answer, Pebble Pen? A standard is a set of agreed requirements or specifications, either should be fine, for hardware and software. They provide a standard way of doing something, and they make it possible to create products which are compatible with each other. For example, a USB port that works on all devices. And examples, you could have character sets like ASCII, protocols such as TCP/IP, cables like Ethernet, USB, and file formats such as JPEG or MP3. Pause, purple pen, add to your answer now, please. Okay, so we know what a standard is. A good example of standards that we talked about there are protocols. So we know what our protocols are, a set of specifications or requirements. We know what they are used for and examples there. So one example of a standard is a protocol. A protocol is a set of rules for how to do something. There are protocols in everyday life, such as how we communicate, how we meet people and handshake and bow and stuff, or how people climbers do things like commands and say words as they're climbing on the radio. They're all standards, protocols, how we do things. Even driving a car, there are protocols for the road. How you signal, how we drive on a certain side of the road, how you turn and go around roundabouts and things. There are protocols that we follow in the UK. Following speed limits, signs, etc. Those are the protocols of driving. On computers, protocols are a set of rules for how devices communicate and send data or transmit data on a network. So on the computers, we're talking about rules for how devices communicate and send data on a network. And it covers things like how the devices should start and end sending the data, how it should be organized into packets or frames, and what should do if the data goes missing. Those are things that protocols cover. So put it simply, without protocols, computers would not be able to work. They would not be able to communicate. And the ones that we need to know about are the main ones there. You can see on the screen. We'll cover that more in a minute. So very simply, what is a protocol? Fill in your box. Checking your answers. Protocol, a set of rules for how devices communicate and how data is transmitted or sent across a network. It could be a LAN or a WAN. They both use protocols. Okay, after checking your answer, there are some important protocols that you need to know for this exam. There are lots of them, okay? There are loads of protocols, but there are some important ones you need to know for this exam, and these are the ones here. Let's talk about them. You can make notes on your sheet as you do, or you can check and add at the end. First one, TCP/IP. This is actually two protocols that work together. You've got the TCP protocol, the Transmission Control Protocol, which is the rules for how devices connect on the network. And it's responsible for splitting up the packets, reassembling the packets, and checking that data has arrived correctly. Whereas the IP protocol, the Internet Protocol, is responsible for packet switching, directing the data as it travels across the network. And we'll be revising that again in a week or so. They both work together to make basically sending data across the internet possible. We have then got the HTTP protocol, Hypertext Transfer Protocol. It's used by web browsers such as Google Chrome to access websites and communicate with web servers where the websites are stored. HTTPS is same as HTTP, but it's more secure. All the information is encrypted, so hackers and other people cannot see the data. It's encrypted. And File Transfer Protocol. It's used for accessing, editing, and moving files between devices on a network. So you're transferring files on a network. FTP, File Transfer Protocol. And finally, last ones are all to do with email. SMTP, Simple Mail Transfer Protocol. Protocol used to send emails. Think SMTP, think send. It allows to transfer emails between servers. So your email travels across from one person to the other. So that's for sending. And we have two protocols for retrieving, getting the emails. POP3 retrieves emails from a server. However, once it downloads the email, it deletes the original email from the server. So you can only download it once. However, IMAP retrieves emails but only downloads a copy of the email. So you can use and you can access it from many different devices, from your phone, from your laptop and things, and only when you choose to delete it does it delete the message. Internet Message Access Protocol, IMAP. Okay, on your sheet on the right hand side, copy down please the different important protocols, the basic description of what they do. Okay, hopefully you've paused. Check your answers. HTTP, used by web browsers to access websites. HTTPS, secure version of HTTP, encrypts all the data. FTP, used to access or move files between devices. TCP is the rules of how devices connect on the network. IP is responsible for packet switching. SMTP is for sending emails between servers. POP3 retrieves it and deletes it once it's downloaded. And IMAP only downloads a copy of the email. Checking purple pen, add to your answers now, please. Very last thing today. This is quite a long one today. All those protocols are organized into layers. There are different layers, a bit like a cake. There are different versions of this, but just be aware, generally there's kind of 4 layers that they can be organized into. Data link, network, transport, and application. layers. So a layer is a group of protocols, more than one, that have similar functions or similar jobs. So they're organized into what they basically do. Each layer is self-contained. So it does its job without needing to know what other layers are doing. They work on their own. And each layer serves the layer above it. So this is an example of the 4-layer protocol. So you've got 4 layers here. At the bottom, you've got the network layer, then you've got the internet layer, the data link layer, and the application layer. You can see they're organized into layers. Okay, why is it done in layers? Remember, each layer serves the layer above it. So for example, when you're sending an email, it would start at the top layer. The email will be turned into data. It'd be split up into packets, be given an IP address, then it's sent over the network. And the other end, the layers are used again, the protocols, to put the email, to receive it, to check it, put it back together again, and then to show it to the user on the application layer. So the layers are used to help organize how the data is sent and received, and it works down through the layers. You don't need to know more than that at this point for GCSE, however. So why use layers? It breaks down communication into manageable pieces, so you can concentrate on one specific area without having to worry about the others. Each layer is self-contained. It means you could change a layer without affecting the other layers. And it also forces companies to make compatible universal hardware, things like we said with USB and Wi-Fi and stuff. Each layer is self-contained is the main one I would try to remember though. Okay, so for example, a company could make a new protocol or a new software thing for like Skype, and it would still work with all the other layers. Or a new version of an IP protocol could be brought out, IP version 8, and introduced at layer 2 without affecting all the other layers. So you can change one layer without affecting all the other ones. Okay, so very simply, what is a protocol layer? Try and give me some advantages of using the layers. And can you give me an example of a protocol which could be found on each of the layers in that 4-layer model? Checking your answers. So very simply, what is a protocol layer? A group of protocols which have similar functions or similar jobs. Layers are self-contained. They can be changed without affecting the layers. It breaks down communication to manageable pieces, so it's not such a massive job. And it helps to provide standards for compatible hardware. And the examples you could have there in the application, you could have HTTP, FTP, SMTP. Transport is TCP, network is IP, and the data link layer sending data is either Ethernet or potentially Wi-Fi if it's being sent wirelessly. Completing your sheet, please. Okay, you are done for today's lesson. There's been a lot of stuff today. Final thing to do, please, can you go to LearnConvene as always and complete revision quiz 10. Click check your answers, correct if necessary, 100% is your target. Good luck, see you in lesson.